Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. This podcast is the last episode on our 10-episode series called Unveiling Tech Horizons. Throughout the series, we have revolutionized AEC consulting by delving into cutting-edge technologies such as AI, BIM, digital twins, PM resourcing tools, and more. Today, I am excited to have with me the host of our Geotechnical Engineering podcast, who will be joining me today as the co-host. We'll be speaking with Ronald, a distinguished scientist in geotechnical engineering at PLAXIS, and Micha, who manages the user success group for Seequent Geotechnical Analysis. Our primary topic of discussion will be a software product called PLAXIS and how it can be used to solve common and complex geotechnical problems in soil and rock, including advanced analysis for excavations, foundations, tunnels, and other infrastructure projects. With that, let's jump into today's episode.
Ronald, Micha, how are you doing? Thank you for being on the show.
Thanks for having us.
Yeah, thanks for asking. I'm fine. Thanks.
Excellent. So before we dive into the world of PLAXIS, people are really excited to hear what y'all have to say about the PLAXIS software. Before we get into that in geotechnical engineering, can both of you take a moment to just kind of introduce yourselves, provide a brief overview of your background and your roles in the field? Ronald, let's start with you and then we'll follow up Michelle.
Okay, well, my name is Ronald Brinkgreve. I'm a distinguished scientist at PLAXISBV in Delft, the Netherlands, which is part of Seequent, the Bentley subsurface company. Well, in fact, my whole career, I've been involved in the development of PLAXIS pretty much from its start as a research project at Delft University of Technology. And so in the past 30 years, I've initiated and coordinated most of the research and innovations that the PLAXIS team in Delft has brought forward in collaboration with our academic partners. As a manager of the Competence Center Geoengineering, I was also a member of the PLAXIS management team until it was acquired by Bentley Systems in 2018. And so besides my role in Seequent, I'm also part-time associate professor in geotechnical engineering at Delft University of Technology, where I teach courses on soil behavior, numerical methods, and I supervise PhD students and master students with their research projects.
Yeah, and I'm Micha van der Sloot. I'm Director User Success Geotechnical here at Seequent. After graduating from Delft University of Technology, Ronald actually invited me for a job interview to take responsibility for the quality of the software that they were developing, and I need to bring a strong focus on the geotechnical user experience. And at that time, the numerical analysis and geotechnical engineering became more and more accepted. And at the same time, these geotechnical engineers actually expected better and reliable software to use in their daily work. Now, if we fast forward 20 years later, through different roles, technical support, I've been teaching a lot, doing webinars, and now in my current role is the focus still on the geotechnical user. Still the key. And my team and I have the mission to empower the geotechnical engineers with the skill set and background to properly set up, run, and understand moderate, complex geotechnical engineering simulations. And we do this through various formats, technical support, courses, workshops, but also collaboration with academia and industry.
That's great. So Ronald, can you tell us a little bit more about the inception and the evolution of the PLAXIS software? And then also, we fast forward, how has it transformed geotechnical engineering practices throughout the years?
Yeah, well, as mentioned, PLAXIS started as a research project at Delft University of Technology in the Netherlands, in collaboration, by the way, with the Dutch Ministry of Infrastructure and Water Management. And that was in the second half of the 1980s, the previous century. And so the research combines the finite element method with nonlinear constitutive models for soil and rock to simulate the mechanical behavior of geotechnical structures in infrastructure projects, such as dikes and storm surge dams in the western part of the Netherlands. At that time, the use and performance of personal computers was booming, and so this situation allowed our research group in Delft to develop PLAXIS as an easy-to-use computer program based on state-of-the-art research and robust numerical algorithms. And so we developed that in such a way that geotechnical professionals could use it in their daily work. This was not just the development. We also started to train a small group of enthusiastic engineers in the Netherlands which then quickly grew across Europe and the rest of the world. In the beginning, the software could only analyze two-dimensional models, but with yearly releases, the features and modeling capabilities of the software increased, dealing with more and more aspects of soil and rock behavior, soil structural interaction, groundwater flow, dynamics, etc. And around the year 2000, we made a step towards three-dimensional modeling, although the early 3D versions were simplified and limited. But our international success allowed us to develop a completely new full 3D version, which was released around 2010. And this new version also had a completely new a complete scripting interface, allowing for further automation and interoperability. And so by that time, the PLAXIS company transitioned from a research-driven organization to a professional commercial company. And so by the time it was acquired by Bentley Systems in 2018, it had become a worldwide success and leader in geotechnical finite element software. And as you know, currently PLAXIS is part of Seequent, the Bentley subservice company, and being part of the Bentley ecosystem enables PLAXIS to become fully integrated into a multidisciplinary workflow within a cloud-based digital twin environment. While the Seequent ecosystem enables PLAXIS to integrate into a 3D cloud-based subsurface data environment, which can be used to serve infrastructural projects all over the world during their entire lifetime. I'm also proud to say that last year, PLAXIS was awarded the ASCE and GE Outstanding Innovator Award, which is a recognition for the innovation that the PLAXIS team has brought forward ever since its early days, and thereby advancing the geotechnical engineering profession.
Excellent. So, Ronald, as a distinguished scientist at PLAXISBV, could you share some insights into the key challenges that it inspired the development of PLAXIS? Like, what were you guys thinking and kind of what drove the development, essentially?
Yeah, so you're referring to the early days of PLAXIS. We are talking about 30 years of PLAXIS here. And so, in fact, our early research at Delft University already involved the robust implementation of nonlinear constitutive stress strain models for soils and rocks in the finite element method. And as I mentioned, in those days, geotechnical engineers relied on conventional methods or used simple self-programmed tools to make geotechnical design. It was the time that personal desktop computers became the standard work equipment for every engineer. And so with the increasing computer power available for every engineer, we had the vision that our advanced technology could be very useful for practical geotechnical engineering and design. By modeling geotechnical structures more accurately and realistically, the geotechnical designs could be analyzed in more detail and further optimized. So besides the developments of the software, we also started to provide support and training to the early adopters and initiated user platforms. And so in this way, we created a market that did not exist in those days. And so after the early activities at the university, a startup company was founded in 1993. But a key challenge was to develop a viable strategy for long-term success. And this was achieved by establishing an international network of agents for the distribution of the software, as well as an international network of academic contacts and collaborations to provide the necessary scientific input for continuous development.
Which to me, right, sounds like in academia, you guys identified a really, really unique use case, right? Perhaps this was born out of research and you saw a way for practitioners to ultimately utilize what you guys had figured out.
Right. And so it was not just the software, it was the whole concept of, let's say, the academic input, the academic contact, creating a user platform, involving users in the developments, giving training and support. The whole concept, I think, has led to the success of PLAXIS in the end.
Excellent. And it really is amazing, especially as you think about, right, the environment from which a lot of these, right, discoveries and inventions come out of. And I know, startups are really popular more so today and spun out of academia and university. So it's just cool to see how you guys were able to take, an idea and really some pain points, right, and then turn it into what PLAXIS has become today.
Yeah, and part of that is also that a lot of it is, I think, is technology push. Of course, we listen to our users, and Micha can probably say more about that. But yeah, we also try to anticipate what is good for the users and to come, on the one hand, from a scientific background to translate scientific developments into practical applications. I think that is part of the success.
And speaking of just practical application, Jared, right? I think you have a great question for Micha on basically, right, how practitioners use the software.
Yeah, Micha, when we think about PLAXIS, and when we say PLAXIS could definitely empower professionals in the geotechnical engineering field, what are some of the key benefits to the users that PLAXIS offers?
I think from where we stand is that we want to make sure that our mission is to have more geotechnical engineers using the right tool that they need to do amazing geotechnical work. We empower geotechnical professionals by providing advanced software capabilities, which are easy to use and understand. I think that's really key in making sure that we don't create just complex software for complex capabilities. It should be easy to use and understand. But the basis for this still remains a good background in the geotechnical principles. Think about groundwater, undrained soil behavior, long-term, short-term behavior, how it interacts with the human-made structures. So PLAXIS provides a lot of benefits that include extensive geotechnical modeling capabilities, the wide selection of soil model behavior with understandable parameters that include soil structure interaction, a command-driven application programming interface, an API, that will help to seamlessly integrate with other software, or where actually we see nowadays more users actually develop their own Python scripting to automate the software to help them do quicker turnarounds of their projects. But of course, not everybody wants to use programming, and they stick to the user-friendly interface. I think that still should be the key, to have easy access to the software, because you should only run with automation once you have repetitive work. And we all know from practice that most of the cases that we do, they start as a unique project. So that's also, of course, what software should provide to help you with dealing with this one-of-a-kind projects. Now, part of the historical success, next to the developments of the software itself, is to educate the geoprofessionals in the theoretical background, how to obtain necessary data, and how to use these benefits to make sure that they are used in the right way, and provide the people with the information that what PLAXIS can do, but also what it cannot do. And to unlock this knowledge, we teach the PLAXIS users and provide in-depth technical support so that geotechnical engineers can master it themselves. We always like to think that people should spend their time in geotechnical modeling and engineering, and not on troubleshooting the software itself. So it should be the complete package that we're looking at, from great software combined with the right sort of help and coaching to make it a success for quick turnarounds for successful geotechnical projects.
Thank you so much.
And I was going to say, a great piece of that, Micha, is you mentioned, right, being able to plug in through an API and do some programming, say in Python, right? But you give that option to maybe your power users, but you still make it very simple, it sounds like, for anyone who just wants to get started, perhaps without a programming background.
Oh, definitely. I think one key aspect that we think of is always like undergraduate students. They just trying to learn and master geotechnical engineering. We first introduced the numerical modeling using tools like PLAXIS. Then you don't want to have a completely command-driven application. It should be easy to understand, easy to use, so they focus on the learning path to become better in geotechnical engineering, and to also deal with all the different soils that we have all over the world with all kinds of typical behavior. So that's something that you want to simulate using PLAXIS. And then you don't want to first do a 3-year course on Python programming.
And speaking of numerical methods and numerical modeling, Ronald, so you have a background in constitutive modeling and numerical methods, right? So how has your experience contributed to the scientific development of PLAXIS, and how does it enhance the capabilities of the software for geotechnical analysis?
Yeah, it's a good question. Thank you for asking. Maybe I should first clarify the term constitutive modeling. So within the finite element framework, as a general framework to calculate engineering problems like settlement, consolidation, deformation, stability, bearing capacity, groundwater flow, well, it's in fact the constitutive models that form the nonlinear relationship between stress and strain components. They actually represent the mechanical behavior of the soil and rock qualitatively, while the model parameters are used to quantify the soil's stiffness and strength characteristics. So constitutive modeling has always been a common theme in the PLAXIS developments. And over the years, the models have become more and more complex, thereby also more accurately simulating the mechanical behavior of soils and rocks under various loading conditions. But more complex models are also more difficult to understand for users. Model parameters, the more complex the model, the more parameters there are, and they all need to be determined from site investigation and lab testing data. And several users see this as a burden. So therefore, in addition to the continuous development of constitutive models, we also work on tools to help users with the determination, the calibration, and optimization of model parameters. And as Micha already mentioned, we teach the backgrounds of the constitutive models as well as their capabilities and limitations in our short courses and trainings to our professional users. And for myself, I also teach at the university, and so that means that also this kind of information I teach to my students at Delft University.
So, and as we know, right, anything in terms of engineering modeling, right, common statement, garbage in, garbage out. But it sounds like you guys have essentially, you're helping your users to kind of step through and really create quality models using the software.
Yeah, it's still valid. The garbage in and garbage out is still valid. There are some famous examples in the past. I will not go into the details, but where things have gone wrong. And so you really need to have a good understanding of the underlying models, especially the limitations, in order to properly operate the software. So although the software is easy to use, we always emphasize on having a good background in order to be able to operate the program in the best possible way and to benefit from all its features.
And Jared, I think you've got a great question on user success and how that's essentially translated down to the users.
Yeah, as a manager of the user success group for Seequent Geotechnical Analysis, can you share some specific success stories or perhaps even case studies where PLAXIS has had a significant impact on geotechnical engineering projects?
Yeah, it's hard to single out one or two key projects or even single geotechnical engineering fields. From the 30 years of history, what I believe is that the biggest impact comes from this continuous interaction between academia, industry, our developments over all these years that move steps forward every time. And this academic network, which was key success, spanned the globe. So we had academic contacts in Europe, in Asia, Africa, the Americas, and especially if we zoom in North American academia. Long-term collaboration that we have is with the University of California, Berkeley, MIT, Northwestern University, University of Illinois, Urbana-Champaign, Texas A&M. And actually, PLAXIS 3D was used for a successful back analysis of a complex excavation project at the Stata Center at MIT. So that was, I think, very cool to see sort of that the academia actually brought sort of the back analysis really close to their own university. Through this innovation collaboration, we were able to verify new technologies, get adoption in small and big projects in traditional geotechnical fields, foundation design and retaining structures, embankments and dams. But now PLAXIS is being used in more engineering fields, offshore applications for foundation of wind farms, to design monopiles, earthquake engineering, soil dynamics. Recently, there was a study done on how high-speed trains move over embankments in Germany. So that's, I think, also very interesting to get these characteristics of soil vibrations and make sure that we have safe infrastructure. I think recently you had an interesting topic in your podcast, Jared, with AECOM's Sam Rummel on tailing storage facility, where he talks about understanding risk to prevent catastrophic failures from flow liquefaction problems with tailing facilities. There, PLAXIS has been also being used and actually to understand the triggering behavior of what's going on. And with that, we can prevent future catastrophes. If you talk about fans of the American football, the AT&T Stadium of the Dallas Cowboys was actually designed using PLAXIS. So the big arches they have in the stadium, they had a really tight half-inch deflection criteria, and using PLAXIS and the fine diameter capabilities, they were able to make a design and prove this design so that it could actually be built. If we then look further to other high-rise buildings, PLAXIS is used with a lot and many types of different foundation systems of piled foundations and pile raft foundations. Nice example was the Marina Bay Sands in Singapore. There's this very great infinity pool at the 57th floor, and it's founded on marine clay, so it's kind of a challenging situation there. But using PLAXIS, they were able to have a proper foundation design to make sure that this weight of this huge pool at the 57th floor actually doesn't cause any issues for settlements, and especially with criteria for these infinity pools, which of course, if it just tilted a little bit, the whole illusion goes away. So you must make sure that it still stays in place. Now, if we move forward for more recent success, the Bentley's Year in Infrastructure Conference and its Going Digital Awards gave actually very good showcase of what recent success looks like. This event is truly a celebration of all engineering projects worldwide. Now, if we just have a few examples, there is that there was a deep and long undersea tunnel in Hong Kong, winner of the 2020 ceremony. It's a 21 Czech Lop Link Tunnel. Advanced 3D calculations were done for underground tunneling, optimizing the design, and led to huge time and cost savings and a huge CO2 emission reduction by 1,500 tons.
Great.
Yeah,
a lot of practical examples.
And I think sort of also with bigger infrastructure projects, Crossrail HS2 in the United Kingdom, many different and complex situations had to be analyzed. So 3D modeling is their key, but also the PLAXIS automation using the Python API was critical here because they could run many different variations, do sensitivity studies and risk assessments based on this automation. So yeah, you can see there's so many things to talk about. Now, anything to build needs to be connected with the ground. Yeah. And for the demands that we now have in these complex environments, we need to have very good understanding of how the soil and the human-made construction work together. And we need to know that before we can actually start building an economic, sustainable, and safe construction. And for this, we need our geotechnical professionals, and of course, there are advanced tools like PLAXIS.
And on that point, I mean, it's great because you guys have, sounds like so many use cases, right? Some quite advanced analyses, but could you elaborate a little bit more on the training and mentoring programs that are provided to PLAXIS users by the user success group and how they advance the geotechnical analyses, right? Because you got a pretty powerful piece of software, but you want to make sure your customers are helped along the way. Is that right?
Oh, yeah, that's definitely the case. And, you know, when you start with a complex software, the first thing is like that you think, oh, I must be so knowledgeable and I don't know enough. Or you skip all the difficult parts and you think you can do everything. So we have to find sort of the common ground, and understanding geotechnical behavior mechanics keeps being at the center of understanding all this. That's the basis of everything that we do. All the work that has been done with the research team. Ronald has spoken about that, sort of how we do this constructive modeling, but that starts from an understanding. And this also remains the core of our teaching, how to connect this practical engineering with this specific background so we can empower our users to do geotechnical engineering. Not just run a software program, but really do geotechnical engineering. Nice example, we recently did a training for a big engineering consultancy firm, and based on some geotechnical challenges around tunneling in various nearshore conditions, we took that geotechnical case as a base for their private training, and with that we got their engineers to be up to speed using PLAXIS software and the capabilities, make use of the advanced modeling and analysis more understandable for even more experienced people. And of course, we help them to explore relevant parts of the software that they did not know before. And by having such close interaction with geotechnical challenges, we can actually understand what challenges lie ahead for a geotechnical engineer. And this, I think, also a very key point in our continuous success for our users. So we don't want to serve them today, but we want to sort of look forward in making sure that all the problems that they see coming their way, that we can find the solution actually before they realize it, and then can offer great new capabilities to them.
Which I think leads into your next question, Jared, on innovation.
Yeah. So Ronald, when you think about, geotechnical engineering practices and how they've evolved significantly over the years or decades, really, how does PLAXIS stay up to date with the ever-changing needs of the industry? And also, what innovations or updates can users expect in the near future?
Yeah, again, an excellent question. And yeah, so what we have seen is the infrastructure engineering and design industry has changed from, you can say in the past was a collection of separate disciplines, each doing their own job. Now towards an integrated multidisciplinary team dealing with all aspects of the project. So the engineering design process has become very much data-driven. while the flow of data is quite dynamic. So it's important to rely on a single source of truth for all stakeholders involved in the project. And being part of the Bentley ecosystem enables PLAXIS to become fully integrated in such a multidisciplinary workflow. And also the Seequent ecosystem enables PLAXIS to integrate in a 3D cloud-based subsurface data environment, serving infrastructure projects all over the world. So not just in the engineering, design, or construction phase, but also during the entire lifetime. So the whole integration of that is I think is a change that we have also lived in PLAXIS and now be part of Bentley systems and Seequent. That on the one hand. On the other hand, with our network of academic contacts, as we already elaborated, we stay at the forefront of new scientific developments. So we have the expertise in our group to translate new scientific developments into practical applications. And so you ask about innovations and what innovations can be expected in the future. Well, there is a global trend that companies are looking for how artificial intelligence and machine learning can benefit their businesses. So AI and ML rely on the availability of data. I just mentioned the design process has become very much data-driven. And so there's a lot of data in contemporary infrastructure projects, from testing, sampling, measurements, and sensors. And we, Bentley, Seequent, we have the tools to manage and enhance that data. And so we also see opportunities to use AI and machine learning techniques in our software. And so we are currently exploring and experimenting how such innovations can benefit our users. Maybe talking about users, Micha, perhaps you can add something from your perspective to this question.
Oh, yeah, sure. Thanks, Ronald. We see many challenges ahead. For me, I think key in the future should look like is that continuous interaction with geotechnical engineers is important. We need to stay practical, we need to stay understandable, so that people can use it in a daily practice. And also that will ensure that any new solution that comes up, it will be effectively used and not just a marketing bullet on our feature list. We should make things that people actually to use and have a value from. And as we operate in a world where software meets engineers, and we all know engineers are trained to be problem solvers. This is also how all the engineers approach new requests. They're very pragmatic. They want to have an enhancement based on what we already have or what we already know. But this might not always be the right solution. So we, as PLAXIS, we need to keep digging. We need to keep asking questions about what the actual underlying problem is. So that is what we can focus on to solve that, to actually make the engineering practice better. This sometimes might take a different route than was originally thought. Sometimes it's just a better explanation from our side. Maybe what they want already works. So we can enhance our training, for instance. Or we need to have better automated workflows, because just connecting different parts that are already available. But also, a lot of times, actually, we also need new capabilities to solve these kind of things. Especially if you think about building things around features that will use existing data, that use existing knowledge. I think that will be very interesting space to go into. Also sort of having this direct interaction with geoprofessionals to anticipate future problems and demands. It also nicely aligns with Bentley's and Seequent's approach, that they want to partner with large engineering enterprises to see how software can add value to this mission of these enterprises, going from single projects to complete digital twins of entire cities. So a regular contact, feedback is needed to develop new and deliver new capabilities to solve real problems that are easy to use and are understandable for our geoprofessionals.
And Micha, it's great because it's such a great relationship, because Bentley's continuously working with engineering firms, right? And he and I, we're trying to provide content and information as a source for, people like your partners, right, to come and find information. So it's great because it's this whole ecosystem of everyone working together, right, to make the built environment better. And on that note, what piece of advice would you guys give to aspiring geotechnical engineers who are looking to navigate the dynamic landscape of the field? Because as we've seen, right, even just using AI as an example, things are changing so rapidly. But what advice would you give?
In fact, I would say it starts with the young generation. I see that so there's a trend that young students are less interested in geotechnical engineering, and so they choose more trendy topics to study, which is a pity. Things like machine learning can be applied in geotechnical engineering, and that's also what we are looking for. But so there is a continuous need and shortage of qualified geotechnical engineers. And so to the young generation, I would say, you can make a difference. Look at the nice geotechnical software tools that are available nowadays, which enable you to design the most challenging projects. Make sure you learn about the fundamental geotechnical principles and backgrounds to be able to translate the outcomes of your calculations into a better, reliable, and more resilient infrastructure. And for those who are also interested in software development, I would say there are great career opportunities and challenges in research and development of our software tools.
Oh, yeah. And maybe to add to that, in general, I would say keep learning, stay curious. Ground, I think, is a very interesting medium to build with, or to build in, or to build on top of that. And we also see that a growing world population is going to be more concentrated in big cities. So in those areas, to make a safe and resilient place to work and live in, we need still smart, curious, and creative geotechnical engineers to solve the problems of the future.
All right, great. Well, thanks for coming on. It's been a lot of fun. I'm sure that this is going to provide a lot of value to our listeners and those watching. And I'm sure Nick will say the same. I learned a lot as well. So thank you so much. Keep up the great work, folks.
You're very welcome, and thank you very much.
Yeah, thanks for the invitation.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.